let's check these answers. Again, you should have first solved for solved the x equation for t, and then plugged it into the y equation, and then simplified, and you ended up getting a nice linear equation this time, y equals 2x. So when you go to graph it, you knew it was going to be a line, but you had to realize where the starting and ending points were, right? And in this case, it didn't really have an ending point, so this one we could keep this going further, right? Because it just said, technically, that t was greater than or equal to 0, but it didn't tell us where it stopped, right? So again, this would just kind of keep going. And as long as you showed like where t equals 0, 1, 2, 3, a few of them, and the arrows going in the correct direction. However, it doesn't continue down here to the bottom, right? It's not going to continue less than t equals 0, because again, it gave you that parameter that t had to start at 0, right? And so you're going to first point here has to be 1, 2, and then after that, you can include all the points. That makes sense? Questions? All right, so let's try the next one, which is a little different because it has some sines and cosines in it. So this next one, number 3, consider the parametric equations x equals 5 cosine of t and y equals 2 sine of t. All right, so what we're going to do here, it's kind of the same idea, but we're not going to solve for t, x equals 5 cosine of t. Rather, we're going to solve for cosine of t. And then we're going to do the same thing for the second one. We're going to solve for sine of t. Okay, so you're going to solve each for cosine and sine. So to solve this one for cosine, I just divide by 5. And I get that the cosine of t equals x over 5. And for this one, I just divide by 2. And I get that the sine of t equals y over 2. So far, so good? Okay, so solve them for cosine t and sine of t. Now all you're going to do is your Pythagorean identity. We know that sine squared plus cosine squared equals 1, correct? So we are going to plug these in. Okay, so instead of sine squared, I'm going to do y over 2 squared. And instead of cosine squared, I'm going to do x over 5 squared equals 1. I'm just going to go over here. I'm going to switch the order around just because we're used to putting x first instead of y. So if you don't mind, I'm going to do x squared over 25, since they both get squared, plus y squared over 4. And this is my equation. And who can tell me what shape that equation looks like? It's not a circle, you're super close. It's an ellipse. Or an eclipse, if you'd rather call it an eclipse. Oh. But it's an ellipse, right? So this is actually an ellipse. You guys remember how to graph an ellipse? Okay, so kind of, sort of. Where would the center be? 0, 0. So this one has a center at 0, 0 because there's nothing up here, right? If it was like x minus 3 or y plus 2, right, that would be something else. So 0, 0. In the x direction, how far do I go? 5 and 5. And in the y direction, how far do I go? 2. And then we just get our oval. It's just an oval, right? Okay, so that's what our graph should look like. Okay, so it should have center, x direction 5, 2, nice oval. Let's look at how the parameters work here, okay, for the parametric. So it's telling us what points to use. Now notice these are all radian values because we're dealing with trig here. So when I do 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right, so let's work through it. X was equal to what? 5 cosine t. So when I plug in a 0, what's the cosine of 0? Cosine of 0 is 1. 5 times 1 is 5. When I plug in a 0 to y, the y equation was 2 sine of t. So what's the sine of 0? 0. 2 times 0 is 0. All right, now let's do pi over 2. These are easy ones, right? Pi over 2, pi. So pi over 2 here. What's the cosine of pi over 2? 0 times 5 is? What's the sine of pi over 2? 1. All right, fill in the rest of the chart. Fill it in, fill it in. You know these. These are easy ones. So anytime you have sines and cosine ones, they're going to turn into ellipses. Okay, so check your work. You should have gotten -5, 0, 0, -2, and 5, 0. Good. All right, so now let's graph it. All right, so at time equals 0, my coordinates are 5, 0. So 1, 2, 3, 4, 5, 5, 0. And that's at time equals 0. And then I go to time equals pi over 2, which is kind of weird that time is pi over 2, but bear with me. 0, 2. Well, that's here. And that's time equals pi over 2. So notice I've gone from here to here. What direction am I going? Counterclockwise. Put your arrow. Then the next one I get to is at time equals pi. I'm at -5, 0. Oh, there it is. And it makes sense that that's pi, right? Now, sometimes they are going to be a little flipped if there's negatives, so it might not always correspond exactly. Here I'm at time equals 3 pi over 2, and then I'm back here, time equals 2 pi. And notice this ellipse corresponds to the equation I just had, right? In the x direction I went 5, in the y direction I went 2. And it should all connect. Make sense? Leslie?
Is there like any, so I'm noticing that the cos 5 cos t and 2 sin t, it's kind of like if you were to just have them as separate graphs and be their own.
They would be completely different, right? Yeah, completely be their own graphs. But when we put them together in the parametric as one graph, it's when we get this elliptical motion. Yeah, Julia? You do. Good question. So you always want to tell me what the t's are on there. So that is a part of a parametric graph showing what the time is as you're moving along. So arrows and the t equals. Yes, on the other ones too. Good question. All right, this last one is more of a calculator one. And it looks like a little bit of physics, your favorite. All right, so here we go. See, there's like a ball, and you throw it up in the air, right? This is physics. We love this. This is easy physics, don't worry. Parametric equation, the path for a ball thrown from a height of 5 feet with initial speed of 100 feet per second and an angle of 7 degrees with the horizontal. Okay, the nice thing is they gave the equations to you over here. So here's your x equation, and here's your y equation. Compute the x and y coordinates of the ball when t equals 1, 2, and 3. So 1, 2, and 3. So you can just use your calculators here, you guys, because it's cosine of 70. Like, I don't know what that's going to be, right? So go ahead and plug in a 1 for t and get your x value and get your y value. Oh, I can. Sorry. Thank you. So here's your x equation. Here's your y equation. So take a 1, plug it in there, use your calculators. See what you get. Make sure your mode is in degrees. All right, what'd you get for the x value, the first one? 34.2. How about the y value? 23.2. That sounds good. All right, make sure you're getting those values, and go ahead and do 2 and 3. Say it again. You know, that's not a negative sign. Good question. I don't know what. That's like the side of, I think it's this box from the graph that came out on the side. Yeah, no negative after that. So just 100 cosine 70 times t. All right, check that your answers look like mine do. Hold on. And if I made a mistake, let me know. Those look good? Am I okay? Yeah? Did I make a mistake? They're okay? All right, so let's see where T1, T2, T3 fall on this graph. So they've already graphed it, right, for us, the X and the Y. So time 1, X is 34 and Y is 23. So 34-ish in here, 30, there's 34. And Y, that's not right. What did I do wrong?
Should be like 80 something.
This is wrong. Oh, I know what I did. You guys, these are all wrong. Yell at me. What's this one? 80 something. Give me 83.9-ish something. Okay, 83. I'll go with it. What's this one? These are all wrong, you guys. Thank you, Randy. What'd you get? 120? Thank you. You guys yell at me. Correct me. There's a whole thing of candy up there. Come on, this is your chance.
The last one is 142.9.
Thank you.
Wait, what?
I plugged in cosine instead of sine. That's all. The second equation is sine, and I was doing cosine. Did you do the same thing I did?
I did it.
You did it right the first time. Why didn't you yell at me, you guys? You
I
gotta
did it
correct me.
wrong
Come
on
on
the
now.
first.
You should be used to this by now. All right, so now let's see if they're right. Here's 34, and it should be 82 point. Oh, yes, it should be. There it is. Okay, so that's time equals 1. So that's after 1 second where that ball is. It's going this direction, right? After 2 seconds, I'm 68.4, and I'm up here at about 128. That looks good. There's time equals 2 seconds. That's kind of cool, right? And then at time equals 3 seconds, where are we at? We're at 102, and I'm all the way up here at 142-ish. So there's 3 seconds. Okay, and then we could keep going, right? 4 seconds, 5 seconds, we'd see where we'd be at. So then the question says, how long is the ball in flight, right? So what I'm trying to find here is when does it hit the ground again? So I'm trying to find the time here when it hits the ground. All right, well, what's true when it hits the ground? Which of these equations is equal to 0? X or Y? The Y value is going to be 0. That's my vertical equation, right? So the Y equation is going to have to equal 0 when it hits the ground. So let's plug in a 0 here. So I have 5 plus 100 sine of 70 times t minus 16t squared. Okay, trying to solve this by hand, total pain. So let's use our calculators, right? So we can do a parametric here. And let's type both of these equations into our parametric. I'm going to stop my video because it's getting too long.